Good evening, students. In our earlier classes, we already discussed different property of metal, reaction with oxygen, reaction with water and acid. Students, how they react, what are the reasons behind this? Today we discuss how can a metal react with non-metal. So at first we understand what are the electronic configuration. We earlier discussed in class 9th electronic configuration of different elements. So now I am showing you the periodic table of the elements. Students, in periodic table we can observe a group, that group number 18. Earlier this group known as 0 group because its valence is 0. In this group, helium, neon, argon, krypton, xenon and radon, these gases found in, they are noble gas, inert gas. They do not react. What are the reason? When we find the reason, in all the gases have last shell have 8 electron. So students, when we write the electronic configuration of a metal and non-metal, when they react to each other, ultimately they want to change nearest noble gas configuration. How can they change nearest noble gas configuration? Either they lose or gain or share of electrons to make last shell 8 electron. We can explain by an example. If we take example of sodium element. Sodium, students, atomic number is 11. So what is the configuration of sodium? We can write 2, 8, 1 because KLM, last cell is M cell and that have only 1 electron. So it lose the 1 electron, change into sodium cation and remove 1 electron. So this sodium ion electronic configuration is 2, 8. This electronic configuration similar to neon, a noble gas, similar to neon. So this is stable. Why? Sodium have 11 proton and 11 electron, but when it lose, then it's remaining 10 electron and 11 proton. Overall, proton are increased, so its size decrease. Other we can explain by another element that we can take chlorine. You know atomic number chlorine is 17. So again write its electronic configuration 2, 8, 7. So in this last shell have 7 electron, but it want to nearest noble gas is argon. Chlorine nearest noble gas is argon. So what will do? Either it lose 7 electron or gain 1 electron. So lose 7 electron is slightly difficult. So it's gain 1 electron. It's take 1 electron from sodium or others. Then it's change into chloride. Now its configuration is 288, similar to argon. So this again is stable. Sodium already stable because its configuration similar to neon, and chlorine change into chloride, anion, and its configuration is similar to argon. So all the elements try to achieve nearest noble gas configuration by losing and gaining of electron or sharing of electron. Generally metal lose the electron and non-metal gain the electron. Between metal and a non-metal there is a bond formation, that bond known as ionic bond. Today we discuss about ionic bond in metal and non-metal. Now we explain electron dot structure of this compound sodium chloride, how can formation. So student, sodium last shell have only one electron, so that electron represented by a dot. And chlorine last shell have 7 electron, so that 7 electron can represent by cross like this 7. So total 7 electron last shell have, and sodium 1. What happen? Sodium lose the electron and chlorine that gain electron. Then it's converted into this sodium get positively charged, and this chlorine get negative charge because 1 electron of sodium, that so it appears negative charge. Between sodium and chlorine, very strong force of attraction, that force known as electrostatic force of attraction, or we can say Coulombic force of attraction. This bond known as ionic bond, and that bond found in that compound known as ionic compounds. Students, this compound is not a single molecule. Millions molecules aggregate to each other and they attract and they convert into solid state. So between sodium and chloride, very strong electrostatic force of attraction. Due to that force, it's converted into solid state. Very high melting and boiling point. And these molecules do not pass current in solid state because it's not a single molecule. Millions molecules aggregate to each other, they strongly attracted. Now we can explain by one more example. Magnesium. Friends, magnesium atomic number is 12. So what is the electronic configuration of magnesium? If we write magnesium, then 2, 8, 2. We earlier discussed in 9th class, first shell only 2 electron, then 8 and then remaining. So these are K, L, M. Last shell, valence shell 2 electron. So its want convert nearest noble gas is neon. So magnesium convert into neon. So what happen? It's lose 2 electron and change into magnesium 2 plus or plus 2, you can write any side, and 2 electron release out. So these 2 electron again gain by further 2 chloride. So between magnesium and chloride, this also formation. So we can write the electron dot structure of magnesium chloride in this way. Magnesium last shell have 2 electron, we can write 2 dot, and chlorine we know last shell have 7 electron. So 1 chlorine need only 1, so it's give 2 chlorine like 1 electron. So it's give 1 electron this, other electron to this chlorine atom to complete the octet, because chlorine have 7 electron. After that, how can bond formation? It's convert magnesium appears positively charged. So magnesium change into positively charged, and these 2 chlorine get convert into chlorides. 2 elements get negatively charged, and because each element gain 1 electron. So in this way we can represent electron dot structure. So these structures are known as electron dot structure. Electron dot structure. Why? Because last shell electron we represent by as a dot or a small cross. Why we represent cross and dot? Because one element we represent by a dot, other element represent by cross. Slightly understand the different electron. Actually, we can't differentiate which element have which electron. So in this way, between these two, magnesium and chloride, they have positive and negative charge, strong force of attraction. This is not a single molecule. Millions molecules attract to each other, form a crystal, and they have very strong force, convert into solid state. So students, the metal and non-metal react in this way, lose and gain of electron, give and take. One element give, other one take. So this process known as ionic bond, and such type bond found in that compound known as ionic compound or electrovalent compound. Sometimes this bond name is electrovalent bond. Electrovalent bond also. So those compounds known as ionic and electrovalent compounds also. Now we further explain by one more example. Now students, calcium oxide, how can formation? We will explain. At first, calcium, or you can write magnesium oxides, how can formation? Similar. So students, first we write configuration of calcium. Calcium atomic number 20. So at first we know electronic configuration of the element 2, 8, again 8 and 2. This type configuration you know in 9th class, because when we fill electrons, then electrons fill according to 2n square formula in 9th class. So n is, what is the n? N is the number of the cell, K, L, M, N, O, P. So first cell, then second, third, fourth. Students, when we fill electron like this, first 2, then 8, because third cell maximum 8 electron can, second cell 8, but third cell maximum 18. But if you fill 2, 8, then next we have 10, so 18. If you fill 18, then this is last cell, and last cell, not electron could not accommodate more than 8, so they convert last, this only 8. 1, 2, 3, 4, 5, 6, 7, 8. Although 18 can accommodate, but if you fill more then it's have only 10 electron. So that time this is last cell, so we fill 2 electron more. And this reason you will understand in 11th class. So now this last cell only 2 electron, it's lose the 2 electron, change into calcium ion, calcium plus charge or 2 plus, and lost 2 electron, convert into argon. Why? Because argon have stable configuration. So oxygen, again we take the, what are the atomic number of oxygen, students? Atomic number of oxygen is 8. So write the configuration first, 2 and 6. In this way, to convert into nearest noble gas, either it's convert helium or neon. So it have either lose 6 electron or gain 2 electron. So gain of 2 electron is easy, then lose 6 electron. So it's gain 2 electron, convert into oxide. Oxide minus 2, 2 minus, you can write anyhow. Then its configuration is 2, 8, similar to neon. So both are stable, calcium and oxide ion. Between there is calcium and oxygen. Oxides, there is a force that known as electrostatic or ionic bond. That force known as Coulombic force of attraction also. Now we can represent by electron dot. Calcium last cell have 2 electron. Oxygen last cell have 6 electron. That can represent by in similar way 6 dot. So to complete octet, this lose 2 and oxygen gain the 2 electron. So transfer of the electron, give and take. So calcium get positive charge and oxygen negatively charged. Between calcium and oxide ion there is a strong force due to that very high melting and boiling point. In solid state students, they do not pass current. They only can pass current in solution or molten state, because that time ions are free to move one place to other place. In this way we can explain magnesium oxide, aluminum oxide. You can write other elements like aluminum chloride. How? First you write aluminum configuration, then 3 aluminum we know. Last cell have 3 electron, 2, 8, 3. So it lose 3 electron and 3 electron gain to 3 other chlorides. So between 1 aluminum, 3 chloride, there is force of attraction, that again similar to other compounds, calcium oxide, magnesium chloride and sodium chloride. Now we explain different property of ionic compounds. Students, now we study the physical property of ionic compounds. Different what types of physical? Physical means appearance. Generally the ionic compounds present in solid state. So we can explain like this, how can they exist? Suppose one is sodium ion, smaller, other one chloride ion, sodium and chloride. Students, they found like this, sodium and one is chloride. One sodium, other one chloride, like this. This type crystal of sodium chloride. In this, one is sodium, other one chloride ion. Sodium chloride, sodium in this structure, one sodium ion surrounded by one chloride ion surrounded by 4 sodium ion and to each other. So in this way, in detail study we will discuss in 12th class, but they found like this. Students, when we apply pressure, when they are hammered, then what happen? One ion shift to other ion. So due to this shifting of ion, same ion comes to each other. Due to same ion, there is repulsion and the crystal is dissociate. So they are brittle nature. When they are pressurized, hammered, they are broken down because this layer is shift and same due to same charge, that is split up and they are dissociated into ions. But when we are heating, their melting and boiling point is very high because they have strong force of attraction. In your NCERT book, at page number 48, there is given different melting and boiling point of some ionic compounds. For example, sodium chloride melting point is given, sodium chloride melting point given 1074 Kelvin and its boiling point given 1686 Kelvin. So very high boiling and melting point. Other elements Other compounds also given: lithium chloride, then calcium chloride, calcium oxide, magnesium chloride. You can see in your NCERT book. Why they have very high melting and boiling point? Reason behind this: very strong electrostatic force of attraction, Coulombic force of attraction found between ions, so they have high melting and boiling point. This question comes in your exams: why the ionic compounds have high melting boiling point? Because they have very strong force of attraction between different atoms, ions, between cation and anion. So due to that, they are found in solid state. Third one, other reason is solubility. Students, solubility rule we earlier discussed: like dissolve like. The solubility principle is like dissolve like. What do you mean by this like dissolve like principle for solubility? It means those compounds are ionic bond soluble in polar solvent. Ionic compounds soluble in polar solvent. Polar solvent. What do you mean by polar solvent? Water is a polar solvent. Water is a polar solvent. We will explain, because there is a comparative term: electron movement more towards oxygen side than hydrogen. We will discuss detail in higher class, in 12th and 11th class. And non-ionic compound, non-ionic, or we can say covalent compound, covalent compounds soluble in non-polar solvent. Non-polar solvent, like carbon tetrachloride. Non-polar solvent is carbon tetrachloride, benzene, ether. And covalent compound means hydrocarbon, petrol, diesel, kerosene, and benzene. Such type compounds we will discuss in next chapter. Carbon compounds, they soluble in non-polar. And ionic compound soluble in polar solvent means water, because water have two types, polar nature. So that is principle. Next property of ionic compound is conduction of electricity. Students, ionic compound pass current in solution. How can pass the current? Because in a solution we have take two different electrodes and they connected by a battery. In this connected between these we fill any electrolyte, like any electrolyte. That electrolyte means ion, like sodium chloride, potassium chloride, magnesium chloride. This electrolyte, that ion, that have ion, cation and anion. So there is present cation and anion. When we pass current, this electrode we can use any metal or a carbon graphite. We know they can pass current. So when current pass, then these ions move oppositely charged electrode. Sodium ion like move towards cathode and chloride move towards anode. So in this way they can move, means they can pass current. Students, in solid state these compounds do not pass current, but in solution they can pass. Why? Solution's movement of ions is free. In solid state they are tightly bonded, cannot movement, can't free. Another method, they can pass current if we heat the sodium chloride in such a way, then the salt change into molten state. There is aqueous solution, but in this Students, when we heat the sodium chloride, then it converts into molten state. If this molten state means in liquid state, so that time it can also pass current in liquid state, but in solid state could not pass. Only in solution or molten state, when ions are free, then it can pass current. So there is ion is free when that is liquid state. Movement of ion can oppositely charged electrode possible when they are either in liquid or in solution. In this way, if we summarize the property of ionic compound generally solid, strong force of attraction, high melting and boiling point. They are soluble in water or a polar solvent, because like dissolve like principle, that ionic compound are polar nature, so soluble in a polar solvent. Other one, they pass current. In this way, students, this chapter is complete, because metallurgy in this chapter is reduced this year, but we will teach this, we will study this remaining part of the chapter, metallurgy, occurrence of metal and corrosion, in detail after your half-yearly exam. So if you have any problem, then write in comment box. We will explain in next video. So up to your half-yearly syllabus is finished. Revise the syllabus, and if you want any problem, then you can ask personally me or write in comment box. Then definitely I will solve your problem and take in your next video. So like and subscribe, share the needy students. Thank you. Have a nice day.